Alright, grade 10s, my beautiful, beautiful grade 10s. Okay, so we are still doing trig graphs. Alright, so we've done sine, we've done cos, and now today we are going to do tan. Alright, so tan, okay, is just short for tangent. Okay, so the full word is tangent, right? That's where tan comes from. Okay, so let's just jump straight into it. So if you get out your calculator and you type in tan, you press the tan button, and in those brackets you put 0. What do you get? You get 0. Right, if you type in 45, tan of 45, you get 1. Right, now if you type tan of 90, something funny happens. What happens? Right, you say you get math error. Okay, so you get something undefined. Okay, undefined. Alright, now let's carry on. We'll get back to that now. Alright, so 135, you get -1. And you go to 180, you get 0. Okay, so 180 we've got 0. And 225, what do you get? You get 1. Now I get to 270 and you put that in there. What do you get? You get undefined again. Okay, undefined. Right, we'll get back to that now. Right, and if you put 315, what do you get? You get -1 again. And what do you get when you type 360? You get 0. Okay, alright, so now let's talk about this undefined business. Okay, so remember when we were doing hyperbola? Okay, what were those new things that we introduced in a hyperbola? Okay, there were two new things, two lines where the graph never touched. What are those things called? Asymptotes. Right, so tan is the only trig graph that is a little bit different. Okay, so sine and cos, they look sort of the same. That's a little wave, right? Okay, it's still different though. Right, but now tan is the one that's completely different. Okay, so we've got asymptotes to worry about. Alright, so please remember tan graph, asymptotes. Okay, it's the first thing I want you to think of when you hear tan. Okay, tan, asymptotes. Alright, so we've got our asymptotes at x is equal to 90 and x is equal to 270. Okay, so now let's remember that. Okay, so let's see what this looks like on our graph. Okay, so we started at 0, 0. Okay, so we started 0, 0. Cool. Everything fantastic. Right, I can label there 0, 0. Cool. Right, then I go to, sorry, other way. We go to 45 and 1. So I go to 45 on my x-axis and I go to 1. Right, I'm going to make my 1. Okay, let's make it 1 here. Okay, that's fine. Okay, that's 1 over there. And then -1 will be there at the bottom. Okay, so I can label that now. I can say there, that's 45 and 1. Now, when we got to 90, we got undefined. So that's going to be my asymptote. Alright, so it's going to be where my graph never touches. My graph is not going to touch this. Okay, and we label asymptotes with a dashed line. Okay, so a little dashed line straight on that 90. Straight down. Okay, alright, and straight after that 90, whoopsie, we've got 135. Okay, so 135 and -1. Okay, so 135. Okay, 135 is going to be here in the middle and -1. Okay, and I can label that 135 and -1. Alright, then I go to 180 and 0. Right, so 180 and 0 there. Right, and then I can come up to 225 and 1. Okay, so 225 is going to be there and 1. Alright, so I can label there 225 and 1. Alright, and then I'm going to have 270 and undefined. Okay, so I'm going to have another asymptote there at 270. Okay, 270. I'm all the way down, all the way down, all the way down, all the way down. Alright, and straight after that I've got my 315. Let's see what the value was there. 315 and -1. Alright, so my -1 is going to be there. Okay, and that's going to be 315 and -1. Alright, label that. Okay, and then I go to 360 and 0. Okay, 360 and 0 there. Okay, and you can label that as well if you'd like. Okay, 360 and 0. Okay, now this is where it's a little bit different. Okay, now it's not a wave anymore. Okay, so we're gonna curl this a little bit. Okay, and we're going to go as close to our asymptote as we possibly can get it. Okay, never touching there. Okay, and we're going to put an arrow. Okay, because it's going to keep going, it keeps going up forever and ever and ever. Okay, same thing here. We're going to come as close to our asymptote as possible. We're going to come up, we're going to curl a little bit. We're going to go through 180. Okay, and then we're going to curl the other way. Okay, and we're going to get close to our asymptote again with our arrow and our arrow there. Not touching, okay? We're going to get close to it, okay? We're not doing this. A lot of you guys do this. You come and then you curve out. No, I don't want that. We're not doing that, okay? Don't want that, okay? Nice and close to my asymptote there. Okay, same thing here. Okay, nice and close to my asymptote. Okay, and I'm going to curl into that and then 360, and I'm going to put an arrow there. Okay, so this graph here goes all the way down. Okay, keeps going down to negative infinity, and it keeps going up to positive infinity. Okay, so it looks a little bit funky. Okay, that's fine. You guys also look funky, some of you. Okay, so no, just joking. Okay, so now we're going to now copy and paste this on this side. Okay, so I'm now going to pretend that this negative 360 is my 0. Okay, so I'm going to start over here. Okay, and I'm going to come up here. Right, and I'm going to have an asymptote at negative 270. Okay, and then I'm going to copy here. I'm going to put that point over there, and then 0, 180. Come up here at 1. So I'm just copying from here. Okay, I'm just copying. Alright, and then I'm going to have an asymptote here at negative 90. Right, and then this point over here is negative 1, so that there is going to be negative 1. And then that there is 0, and then that there is going to be 0. So I just copied and pasted. Okay, and then I'm going to curl up here, curl up, right, and I'm going to curl up here again. Nice copy and paste. Okay, over there and over there. Okay, and I'm going to curl out here again, nice and close to my asymptote. And there we go. Okay, so that's my tan. Okay, so if you look at your tan, right, it looks completely different to sine and cos, right? It looks a little bit funky. Okay, but that's okay. Alright, if you look at negative 90 and you look at 90, okay, can you see I've got two asymptotes? Okay, can you see I've got this little squiggle here? Okay, I'm going to call it a squiggle. Okay, I'm going to highlight the squiggle. This is the squiggle. Okay, that's in between negative 90 and 90. Okay, what's the distance between negative 90 and 90? Okay, so how many degrees is between negative 90 and 90? Okay, 180 degrees. Okay, and then what happens? Then the squiggle returns. The squiggle returns. Okay, sounds like a horror movie. Okay, it comes back. Alright, and what's the distance in degrees between 90 and 270? 180 degrees again. Alright, and then what happens again? Alright, then it repeats itself. It keeps going. It returns. Alright, it returns itself. And over here again, it comes back. Right, like a horror movie. Okay, it comes. There we go. Right, so that's my tan graph. Okay, so it repeats itself every how many degrees? 180 degrees. Can you see it's completely different to my sine and cos? Okay, because sine and cos repeat itself every 360 degrees. Okay, so let's answer a few questions on my tan graph. Okay, so here's my questions. So the maximum value of my tan is what? What is my maximum value here? Maximum value. Anybody? There is no maximum value, okay? Because this keeps going up, okay? Forever and ever and ever, okay? It goes to infinity, okay? So if you'd like, it's not mathematically correct, okay? But my maximum value is going to be infinity, okay? Infinity isn't an actual value. It's the collection of all the numbers, okay? So this isn't mathematically correct, but just for some of you, for some of your brains to comprehend what's happening here, my maximum value is infinity, okay? So my minimum value, right? This graph goes all the way down, okay? It keeps going down, okay? Forever and ever and ever, all right? And it gets to which value? Negative infinity, all right? So that's my minimum value, all right? So technically there is no minimum value because it just keeps going. It keeps going, all right? But for some of you, okay, negative infinity. Okay, but in your exams, they won't ask you. Usually they won't ask you what's the maximum value, what's the minimum value for tan, because there isn't one. Okay, it just keeps going. Keeps going. Okay, all the way up, all the way down. Alright, so my range of tan. Okay, so it's all my y values in between my max. Sorry, I'm just yawning here. Between my max and my minimum value. So it's all my y values in between my minimum and my maximum value. Okay, can I touch infinity? No, I can't touch it. Okay, so it's just going to be my less than signs. Okay, I'm not going to say equal to. Okay, because my graph doesn't touch infinity. It can never get there. Okay, are you with me? Okay, so that's my range, okay, of my tan graph. Right, now amplitude. Okay, so if you look here, my amplitude. Okay, does the tan graph have an amplitude? Okay, because what is amplitude? It's the distance from the x-axis to the highest point. Okay, my peak or my valley. Alright, so if I look here, here's my x-axis. Okay, and I want to go to my highest point. What is my highest point? Infinity, right? There is no amplitude. Okay, there is no amplitude. Okay, so if you'd like, so your brain can comprehend, the amplitude there is infinity. Okay, there is no amplitude. They won't usually ask what is the amplitude of a tan graph because there isn't one. Okay, it's infinity. Okay, all right. Then also, so these questions here, right? These three, they won't usually ask. Okay, it's very rare. Okay, because there isn't a value. Okay, then tan repeats its basic shape every, we already determined that, every 180 degrees. Okay, it returns, okay, like a nightmare, like a horror movie. It comes back every 180 degrees. Okay, this repetition is called the period. Right, so I can say that the period of y equals tan of x is 180 degrees. Okay, all right, so there we go, guys. We have just concluded our trig graphs. Okay, so what I want you guys to please do is I want you guys to now go and memorize my sine, my basic shape of sine, my basic shape of cos, and my basic shape of tan. All right, so this is my basic shape of tan. Right, so we started at 0 and we come up. Okay, and there's a point there. Okay, so this is 0, 0. Right, this is my 45 and 1. Right, and then I've got an asymptote. Okay, and then I've got another squiggle. Squiggle. Okay, 180 and 0. Okay, I come up here to 225 and 1. And here at the bottom I've got 135 and negative 1. Alright, and then I've got an asymptote. Okay, so my asymptote there is at 90, my asymptote here is at 270. Right, and then I've got another squiggle over here. Right, so that there is 360 and 0. Right, and over here we've got 315 and negative 1. Alright, so I know it's a lot of points to remember. I understand, I really do. Right, I understand. So, an easy way to remember all of your points is they all are 45 degrees away from each other. Okay, so if you start at 0, 0, okay, so I didn't remember all of these points. All I did was I added 45 to my 0. Okay, so if you take 0, you add 45, you get to 45. And I already know it's going to be at 1 because it's curving up. Okay, because I know my basic shape. Okay, if I say 45 and I plus 45, where do you get? You get to 90. Okay, at 90, I know there's an asymptote there. Okay, then from 90, I add 45. I get to 135. And I know, because I know what the basic shape looks like. Okay, I know it's going to be at negative 1 there. Add 45 there, you get to 180. I know it's going to touch the x-axis at 180, 80 and 0. Right, I add 45 there, I get to 225. 225, I know it's going to be at 1 because I know my basic shape. I add 45, I get to 270. I know that there's going to be an asymptote there. I add 45 to 270, I get to 315. And I know it's going to be -1 because I know my basic shape. Right, I add 45 there, I get to 360, and I get to 360 and 0. Alright, so it is very important that you guys know what the tan graph looks like, just the shape of it. Okay, and the same with your sine, just the shape. Where does it start? Where does it end? What are my high points? Okay, my high and my low points. Same with the cos. Where does it start? Where does it end? What is my high point? What is my low point? Okay, and then the same for your tan. Okay, where are my asymptotes? Where do I curve? Where do I curve up? Where do I curve down? Okay, where do I touch the x-axis? Okay, those things are very, very important. You guys need to know that. Okay, so there we go, guys. Those are your trig graphs, your 3 trig graphs. Okay, and I hope these 3 videos help for your tests and your exams. Okay, guys.